Hi, and welcome to another edition of the Community Office Hours. With me here is Sam Snyder, uh, and I'm Tim de Beek. And we're going to take you through what's new in Open Rewrite and Moderne in the past week. So the theme for today is love your code again, to be able to modernize your code such that it feels like something you actually want to work with again, even though it might have a rich history to it. And one way to do that is to write recipes, modernize things. And an easy way to do that is using the Java template, which we'll zoom into a bit and Sam takes over. But first, I want to take you through some of the things that are new this past week. And for that, I'll briefly share some quick tabs that might be interesting for you to look at as well. So first up, we have a very interesting blog by our colleague Justine, who wrote about how we are now using AI to improve the search that we have at Moderne. And maybe Sam, you want to share your thoughts on this one as well?
Yeah, sure. Yeah, I think that this solved a really important problem for us, as we're now approaching, or we're just over, I think, 1,700 recipes in the recipe catalog. It became, well, even very quickly, it became hard to find the particular recipe you wanted. Uh, with the old code search, which was Lucerne based. We did Lucerne indexing under the hood, and so that was what the search bar on the Moderne app would query when looking up recipes, uh, and that was fine if you knew the exact name of the recipe you were looking for. But if you couldn't remember if it was update dependency version or upgrade dependency version, or maybe even didn't know that that's specifically what you wanted, then it was very hard to find the recipe you were looking for within a catalog of hundreds, and now 1,700 recipes. So we knew that that wasn't going to be the way forward long term, and that we would need fuzzier matching. So fortunately, our brilliant colleague Justine implemented an AI, a large language model based search for recipes, which is really good at doing all of that fuzzy matching. So now you can just broadly describe the recipe you're interested in, or even ask it a question and get results. And I am very impressed with the latency of how quickly those results are returned now. And so this blog post is really interesting for me, since I don't know a whole lot about AI models, but a peek under the hood as to how you solve a practical problem like this using a language model. As a, I don't know, old school programmer, I'm familiar with the idea of an index on a database, but this new world of AI stuff is more novel to me. And so this example of the considerations that go into it, how it was built, what it can accomplishes, how it compares to the more traditional system, is really educational. So I found this really fascinating. Strongly recommend everyone to check out this article. Yeah.
Yeah, thanks. So that's available at moderne.io/blog. And then, it's currently the last one, so you don't have to type all of that. But go check it out. It's really fascinating read as well. And then another thing that's new over the past couple of weeks, but we're finally now rolled it out to all of our projects, is that we have automated the code reviews on any kind of open source contributions that come into the project. So as you might know, we have some 40 repositories for Open Rewrite, and all of them see traffic from community contributors, but some of them might not be aware of some of the conventions that we have. So what we've done to keep track of all of the contributions is to automate some of the reviews. And for that, of course, we're using Open Rewrite, we're using recipes, and we run that on every PR that gets opened or refreshed. And you can see the results of that right here. We have a pull request to to migrate folks from Hangpress to JUnit 5. It's a pretty decent one. But there's some of the changes that we are where it's not conforming to what we would like to see. Using, for instance, a consistent name for a particular variable, and then that needs to be applied everywhere. And of course, when you run a recipe, you get a diff, and that diff now allows us to add in these automated improvement suggestions, such that you can just go to the Files tab, apply all these suggestions from there. And that is now something that I don't have to keep in mind anymore when I'm reviewing code commits. So that is pretty neat to have. Now, we're going to do a write-up of this as well, so that you yourself are able to do this on your own projects too. But it's just really neat to see what you can do when you combine recipes with these automated flows.
Yeah, totally. You can stop wasting time either writing or reading particularly pedantic code review feedback about conventions, curly brace placement, spaces between an if statement, any anti-pattern you're sick of seeing or best practice you want to really be enforced universally. This is another way to use Moderne and recipes to accomplish that.
Yeah, absolutely. And it also takes some of the discussion that you might have around this, because folks are more inclined to accept feedback from a bot that's just helpful and click here to apply this change, rather than have that one guy again tell you that you're not using the correct number of new lines. So it's really neat to
Yeah.
see this automation going.
Yeah, you
So
can
yeah,
kind of like glimpse almost towards a possible future where everyone just sees the code with their preferred styling and idioms. Like right now in our source control repositories, we store a text-based representation of code, and Git manages the changes. But if it was an LST representation of code that was stored in a repository, you can imagine that you would pull it down and like hydrate that into text that you would manipulate in your IDE, and you could just set your preferred style. Like I prefer to see code with curly braces on the next line, say, and it would just be presented to you that way. And then anyone who reviewed it would see it presented in their preferred format. Not saying that we're announcing our GitHub competitor early, here in this community office hours or anything, but something to consider how different representations of code could facilitate things like that.
Yeah, absolutely. And it ties into things like accessibility as well, where some folks need maybe a larger spacing or need a really small spacing. And being able to be more flexible in what you accept and how you present it is just one way to do that. So
Yeah,
really neat.
totally.
Then another thing that's new, but we're going to zoom into that on a different call probably, is that if you now go to the Moderne marketplace, you will find that there is some 300 recipes related to running JavaScript code mods. And that is a really neat way where we're now able to use the automation that we already have with the platform to run recipes at scale and view the changes and roll out pull requests, and open that up to a new ecosystem by leveraging code mods in this way. And it's just really neat to see what we're quickly able to do this way now. But we're going to dive into that in more detail later in a different session, I suppose.
Yeah, for sure. So if you're a JavaScript developer or just friends with some, you can look forward to that. But yeah, I think that we have a couple examples now between Refaster and this, where we encounter other refactoring tools out in the world, and rather than necessarily trying to replace them from the ground up with our thing, it's like let's just absorb that. We'll do open rewrite recipes and code mods and Refaster templates. I don't know what the next refactoring tool will add some compatibility with may be, but wherever we find, as we expand into new language ecosystems, wherever we find existing refactoring tools, I'll always be looking to jumpstart our recipe catalog by building compatibility with them, however that might make sense.
Yeah, it's really neat to now have this capability and see what it might do next. So yeah, well, look out for that and more like this in the future.
Yeah.
And then, as always, we have we're churning out new videos related to various topics on our YouTube channel. If you're viewing this on a different channel, then maybe it makes sense to jump to our YouTube channel to have a look at those as well. And just over the past week, we've added videos. One in particular is a frequently asked question on what is the distinction between Open Rewrite and Moderne. We have now a quick 2-minute video that will take you through some of the details there. So go have a look there if you want to know what the difference is, and we can tell you that exactly. And there's some visualizations in there with soup, I believe. So really, really neat to see.
Yeah.
And another video that I helped create is the migrate to Java 21 recipe, where it's just a collection of small changes that will take you from whatever Java version you're using, but most likely from 17 to 21. And we introduce sequence collections, and we move you away from some deprecated constructors, and just a quick overview of the recipes that we have surrounding that. So that's another one that you can go watch, and is really neat to see what's possible these days. Then another one this week, I think Sam, you helped create.
Yep. The composing the recipes in the builder video. Yep.
So that's
may look familiar to some of you. I think I might have covered some of this stuff in a previous office hours.
Yep. But it's now we have a short video where you can, if you want to go in depth here, you can send this one specifically to folks if you want to learn more.
Yeah.
And then finally, we had a video from a customer of ours who are using the Moderne platform, and they go in depth through some questions on how they are using Moderne and what makes that work well for them. So that's another one that you might enjoy, seeing what is possible with Open Rewrite and what you could then do next if you add Moderne to the mix as well.
Totally.
So yeah, that's the few things I wanted to take you through this week. And then maybe Sam, you can share your screen and we can look at
yeah, I'm ready to go.
Java template for this week.
Yeah, so those of you who were here last week may remember the recipes we were looking at. I think we were actually looking at maybe this one where we were using JavaTemplate to produce. I should zoom in my text a little bit. Where we were using JavaTemplate to convert a snippet of Java code into LST elements, sometimes interpolating in other LST elements in order to affect a refactoring operation. And that's cool and useful. But like it is, I thought we would discuss both maybe a little bit about how that works, how to kind of debug or understand what's going on under the hood here when you may run into problems, and also just get a broader sense of what is possible. So today I thought we would actually look through some of the Java template tests, and this is in the main rewrite repository where we exercise a whole variety of scenarios with Java template, doing different kinds of replacements, replacing different things. Like this one is replacing an assignment inside of a conditional or a Boolean. Inside of a conditional's Boolean expression, and a whole bunch of other different interesting things that you may not have considered you could potentially do with Java template in here. Changing the type of something while leaving everything around it the same. So it's a very powerful mechanism for editing and rewriting of code. And I thought that it would be good to show some debugging techniques for these and to talk a little bit about how it works. So let's maybe start with that. Talk a little bit about how it works. So when you are using a Java template, the snippet you provide gets built, based upon some insertion scope, gets built into a full valid Java source file, which is then passed to the Java parser, and then the relevant element is extracted and returned to you after parsing. So you could accomplish a similar effect as Java template manually by like newing up a Java source file. Like for this guy here, if we wanted to get an LST element for value equals zero, it would be pretty similar in terms of just pure cause and effect to new up a new Java parser from Java version and build parse. And of course, we have to provide a full valid Java source file here. So, class A is equal to int value. First, get. So this is kind of showing what you would do if you didn't have JavaTemplate available to achieve a similar sort of effect. And this is, you might say, why would I care about that? I do have JavaTemplate available. It's like, yeah, you do if you're editing Java, but if you're like writing a recipe where you're editing a YAML file or a JSON file or a properties file or maybe Groovy or Kotlin, where we don't yet have specialized versions of JavaTemplate for those languages, this kind of trick of newing up a parser yourself and then extracting the snippet you're interested in uh, from it can be handy, and it helps us to understand what Java template is actually doing. So, if we were to say source file, get classes, get 0, get body, get statements, get 0. Okay, and this would actually, return us an assignment similar to what Java template is doing under the hood, because the changes, we've manually built up the snippet around it, parsed it, and done the extraction. So, kind of automating some of this legwork is part of what Java template does, while providing the additional faculties for doing substitution of parameters into the template and for capturing um, you know things like in this case, we've got value equals 1 here. Well, value is defined here, so I guess that's actually a good point. We need to have the value definition, and then to have built around this guy. Like, this isn't actually what I've built here isn't equivalent to this, because what I'm extracting right now is the variable declaration for value, not the assignment of value equals 0. So, if we put in a value equals 0 and then extracted this bit, we would be getting something similar to this. So I put this code here not to recommend that you do this, but just to kind of maybe make it a little bit more concrete what Java template is doing. So now that you kind of understand that, let's talk about, or let's show a debugging mechanism that exists on Java template that you might not even be aware exists. And that is to say, there's this do before parse template, which gives you, well, let's show you what it gives you. So I am just going to, let's just hit this in the debugger. And so this just gives you a callback where right before, after we've generated the snippet that's going to be going into the Java parser to produce your LST, the full snippet that gets generated, you can retrieve that with this do before parse template function. So for example, if if I get a bug report that Java template isn't working right, uh, this is one of the first things I go look at. And we see in here this string of Java code, which is not super easy to read in the debugger. So let's go paste this into a Java Scratch file and have IntelliJ pretty print it for me. Oops. And so this is what we actually, maybe we'll get rid of some extra new lines here so this is a bit more dense. This is what we actually are asking what Java template generates and passes to the Java parser. And so you see that there's comments around the thing that we're actually going to extract at the end, and searching for those comments is how Java template identifies which LST element you actually asked for. And then based upon the cursor that is passed in to the Java template apply function, is how it knows to build around the value equals 0 to say, okay, well, where is value equals 0 going? Well, it's going into the method foo, and before the insertion scope it's going into, this double value was declared. And so when building the snippet, there's this process of like going inwards out from the snippet you provide, surrounding it with the relevant stuff from the surrounding lexical scopes, so that the snippet will be able to, see the variable names like value that it references. And no imports are necessary for this one, but if there were imports or things like that, those would be similar. Now, these M and P classes are not needed here particularly, but are relevant when you are relevant to the parsing of snippets when LST elements are going to be interpolated in after the fact, like in Rewrite Recipe Starter in this version where, and this overload for new array list iterable, these guys, where you're using one of these format specifiers to say, hey, an LST element of type collection is going to be interpolated here, after templating. uh, this is, we use this information to, just place, one of these method invocations in that spot, so that so that the Java parser, so that we can parse the snippet without actually having to print out the whole LST element into that spot. Um, yeah, so it's kind of an implementation detail of of the um, of how the variable interpolation works. Um, and so, I've just kind of talked about the cursor and that providing context for the insertion scope of the templating operation. I think the cursors are also an area of confusion, or just something that a new recipe author is gonna see used, but not necessarily understand what that is or what that means. If you look through recipes, you'll see this get cursor method called, semi-frequently, particularly in conjunction with JavaTemplate, to do just that, to supply uh, the context around an insertion scope. So let's look at what one of these cursors looks like. So right now, we're inside of a Java visitor visiting an assignment, and this is the assignment being visited. So if I, in the debugger, maybe go up to, maybe go up to here, and if I evaluate this get cursor method, I guess I can't make the text in this window bigger, but if I evaluate this get cursor method, we will see that a cursor has a pointer to a value and to a parent cursor. And the value is when you call just get cursor from within a visitor, the value it's going to point to is the LST element currently being visited. And the parent is going to be a cursor containing the LST element that contains the thing being visited. So this assignment is contained within a JWrite padded, which is a white space recording construct. Not typically very interesting, but so that the assignment is contained within some parentheses, which, if we remember the code snippet here, the assignment is contained within these parentheses. Those parentheses are contained within this binary expression. That binary expression is contained within the control parentheses of the if statement, and so on and so forth, until we eventually get up to the root of the entire document, which is the containing source file, or the for a Java source, the j.compilation unit. And so this mechanism is used by JavaTemplate to find the elements that surround the insertion scope. It's used to find this method declaration, and then looks through the method declaration to find the variable declarations within it, and to find that the method is contained within class A, and so on and so forth. And so knowledge that this cursor is there can be relevant to a variety of recipe authoring scenarios, not just JavaTemplate, um, but also anytime you might want context about, okay, like I'm visiting an assignment, or I'm visiting an assignment. What class am I declared in? You can answer a question like that with get cursor dot first and closing. So if I'm like, I'm visiting an assignment right now. I'm inside a class declaration. Give me that class declaration. You can use this first and closing method to just traverse up above you and find there might be more than one class declaration, if you were nested in an inner class, but this will find the first class declaration that encloses you, or encloses the element you're visiting. So that can be a very useful piece of context for answering a variety of questions that you might have while running a recipe. One other kind of facet of cursors while we're talking about this is this messages field. Right now, this is null, and if we look at each cursor in the stack of items currently being visited has its own messages field, all of which are currently empty. But this is a mechanism, and I remember last week Jonathan Lightshoe was in the audience and mentioned how confusing he finds it when cursor messaging is used within a recipe. But hopefully he's here today, and we'll see this explanation, and it will make a little bit more sense. So one thing you can do, like say I am in this place visiting this assignment. If I wanted to say if you wanted to communicate with like a visit method at a higher level than the one you were currently visiting, you could use cursor messaging for that. So what am I talking about? Let's make this concrete. So if I put something here, if I override visit compilation unit, and I call super.visit, so just like before, it will go and traverse down into sub elements, and I want to get back, call UC, we want to get a message. I'll say value, and then we'll say value. And then down here, we could pass a message up to it. I can say, maybe in here, I'll say get cursor, put message on first and closing, j.compl. And so let's just pass up this full template string with cursor messaging back to visit compilation unit. All right, so I'm going to run this again, and I'm just going to stop in the debugger, and we will look at what's going on here. So I've started running this again, and we're inside a visit compilation unit. And again, for a Java source file, compilation unit is the highest level element, the one that encloses all of the rest of the source file. And I've gone to our cursor, and I've asked, hey, are there any messages in here? Is there a message with the key message? And currently there is not, which makes sense because until super.visit compilation unit is called, we haven't traversed down into the sub elements of the compilation unit. So nothing could have set this message yet. But as we go through and visit all of the sub elements, when we get to visit assignment and we do this invocation of JavaTemplate, then we're going to, at that time, add a message onto the compilation unit's cursor and kind of allow us to smuggle information back from visit assignment up to visit compilation unit. So if I step over this step, we go through and do the visiting and do the Java templating, which is going to take just a second. There we go. And now we check again. Now that we've gone through and done that traversal, there is a message on the cursor for us. And it's this text that we saw before from that we supplied in here. So this is a kind of way that when you're writing a visitor, if you're like, okay, I at a higher level need some context, like I need to extract a piece of information from the child elements of the element I'm currently visiting. Uh, Cursor messaging is one way to accomplish that. Um, Yeah, and this can make things this I think that this can cause a hit to the readability of your code, because if you don't keep in mind the relationships between LST elements, um, this doesn't make a whole lot of sense. But then again, if you're not keeping in mind the relationships between LST elements, you may have some challenges successfully writing the recipe in the first place. But I think there is a reasonable debate to be had that in some cases it may be more readable that if you need information from a sub element and you want to query this the sub elements of the LST element you're visiting, that creating a specialized visitor that just does that thing and directly returns the value you're interested in can be more readable, because when you do this, you're kind of inherently having functions do several different things, right? Like this visit assignment both puts this message on the cursor totally as a side effect, and does its transformation and does its manipulation. And so, that a message gets put into the cursor in this way, the only way you would know that is by reading or having been the author of the code. There's something in the method signature that says it has that kind of side effect. So I can see people finding that a little bit gross, particularly maybe if you were a functional programmer who liked the purity of functional programming and indeed, might appreciate that we're largely using in the LST itself immutable data structures and data transformation patterns that are amenable to a functional approach. You might not like this, and if you shared that feedback with me, I would understand where you were coming from, but it can be a really convenient way. You're like, oh, I'm visiting this thing anyway, but I need this piece of information elsewhere. Well, I'll just put it in a cursor message, and it'll be there waiting for me when I need it later. Yeah. So let's see. I don't know. Do we have any questions about that so far? I guess I'm not really seeing anything in the chat
Nothing
on
so
that
far in the
subject.
comments.
Well, fair enough. Let's see. I guess we'll just stop that there.
And maybe to clarify, so the cursor messaging is if you want to inform yourself from data from within the same compilation unit. So we have a call scheduled next week if you want to look across multiple files or maybe even file types. Then you might want to look into scanning recipes, and we'll go into that then. But know that this is unique to a single compilation unit.
Yes, it is. One kind of important thing about the very concept of cursoring is that it is keeping track of where you are in a source file while it is being visited. So as soon as we're done visiting that assignment statement, the cursor at the top of the stack is popped off the stack and thrown away. So cursoring is useful for passing messages within a visitor while visiting is happening. And because everything in there is temporary, you don't have to worry about any information leaking from one source file to another. So that you wouldn't say, like in this case, visit an assignment in one file, and then visiting that file is finished, and we go to visit another file. There's not still going to be that cursor message there because the whole cursor stack was thrown away when visiting concluded. If you did need to pass information between files, you could use the execution context for that, which similarly can accept arbitrary messages on it, but it's generally a bad idea to do that. I have yet to find a use case where it's actually a good idea to pass information from one file visit to another via the execution context. and that's part of that is you can't as a user or an author of a recipe, you have no control over what order files are going to be visited in. So if you find yourself thinking, oh, I want to take information from this file and reference it in another file, I know I'll put a message in the execution context. Don't do that. You're going to cause problems for yourself. Your recipe might work in a unit test if the files happen to be in the right order, but in the real world, when you run it later, you might not encounter the files in that particular order, and you could write a unit test that pass and a recipe that does not work. And to answer that question, how to deal with refactoring operations that cross file boundaries, check back here next week, and we'll talk about scanning recipes, which will cover that important functionality.
Yeah, cheers. And I put the link up there. It's also part of our best practices not to use execution context messaging, but use cursor messaging. It's not yet something that we've automated in the reviews. Maybe that's the next new thing to do. But it's
yeah, good point.
Well, cheers. So with that, I think we've sufficiently shown people what to do with Java template and how to use cursor string effectively. I just want to quickly point out that we also will be sharing the links to the docs of some of the things that you've seen. So we have a page specifically on Java template. We also had a link shown on cursoring. And there's also a specific page on modifying methods with Java template. So if you want to go in depth there, then there's a lot of that to read into as part of a full example. So be sure to check that all out. And then, we should be better set to develop your own recipe.
Right on.
And then rounding off, we have, as always, you can try all of these recipes out through Moderne with this QR code. And then I want to point you towards that we're also going to be at a couple of conferences in April. So first up, we're going to be at DevNexus, April 9th through 11th. And if you want to get a bit of a discount to go in there, I was there last year. It's great fun. Then you can use this code to get your ticket. We'll, over the same dates, also be Open Rewrite will be presented at JavaLand in 3 different sessions, mostly from the community there. So that's really neat to see. And then the week after that, I'll be in Paris, France, to give a 2-hour workshop on recipe development. So if any of that is near you, then go check it out, and you can learn more about all of this over there. So I think that's it for me for this week. Do you have anything last thing you want to share?
No, thanks a lot, everyone who joined us. Thank you, Tim, for joining me here today. And I hope all of you have a lovely rest of your day.
Yeah, cheers. And then hope to see you all next week for scanning recipes. Cheers.
See you then. Bye.
Bye.